Welcome. Alright, in this video we're going to talk about solving linear equations. Specifically, I had requests to do equations that had a lot of fractions in them, so we'll be tackling those. One of them does not, but two of the three do. So I'll show you how to deal with them. Alright, I have 4 steps. I try to break everything down that I talk to my students about in 4 steps. That doesn't mean that each step doesn't have some mini step in it. So if you're a computer person, then it's like calling a function within a function. I mean, sometimes it's just easier to do that. So each of these things, I'm assuming that you will know how to do. If you don't, you may want to take a look at some videos on how to do that specific thing. But all of these rules apply. All right, first thing I do, I tend to distribute first. Notice that when I'm describing this, I say I tend to distribute first. These rules are typically done. The order in which you do them is kind of up for grabs. I've just found that this seems to be the most consistently easy. The next thing I would do is, if there are any fractions, I would tend to clear the fractions. It's not a requirement, but for me it makes it a lot easier. Second little piece here. Combining like terms. When you do this, you want to combine like terms on each side of the equation separately. Again, there are ways to move around this, and as you advance through algebra, you'll pick up on these little tricks that aren't tricks at all, but it's just you choosing to do it a different way. Number 3, you're going to move. We have to move things around. So the idea here is I want all of my variables on one side, I want all of my numbers on the other side, and which side is which does not matter. So that's the other big thing. And finally, once you're done with that, you should have a single term of variables on one side of the equation and a single set of numbers on the other side of the equation. You simply divide by whatever's in front of the variable. I put multiply or divide because you could do both. Technically, you're allowed only to multiply by non-zero numbers. But since multiplying by a non-zero can be like dividing by the inverse, we are allowed to divide as well. Many people, when they get to this, will just divide all the time. This is perfectly fine. Does not matter at all. All right, so here we go. Here's our first one. I'm going to take this 1/2 x plus 3/4 x minus 5/3, and all of that is going to equal 5/6, and we would love to know what x is. So my first step would be distribute. There's nothing to distribute. There are no parentheses, so I don't need to worry about that step. So I move on to the next one. Notice that there are fractions involved. So I'm going to clear the fractions. It is not required that you clear the fractions, but I'm going to do it. So what I'm going to do is I'm going to take a look at all of the denominators involved. This is after I've gone ahead and distributed, and I'll show you the difference a little bit later. So I take a look at the 2, the 4, the 3, and the 6, and I ask myself, well, what is the least common multiple of all of 4 of those numbers? And it turns out that 12 is. So I'm going to choose. And there were only 2 things that scared me in algebra that as I've moved through high school and college. And the first one was something apparently Einstein loved to say, which was, it is easy to see that, and then he would go off on some tangent, and only 4 people in the world would know what he's talking about. So it is easy, my ass. The second thing is, as soon as somebody says choose, there's almost always a condition with that, and you don't always get to know what the condition is. So I'm going to do my very best to tell you, anytime I have to choose something, I'm going to tell you why I'm choosing what I'm choosing. I'm going to choose to multiply both sides by 12. It is not a requirement. You may multiply both sides by any non-zero number you wish. The reason I chose 12, however, is that it is the least common multiple of 2, 4, 3, and 6. So what this is going to effectively do is each time I multiply the 12 into that particular term, it's going to end up reducing down to the point where it has no denominator. The denominator will be 1, and therefore it's just a whole number. So it's a lot easier to deal with those typically. Now, the question I always ask is, when you're dealing with your order of operations, and This is not it, but I'm sure that I'm going to get a lot of nastygrams from other teachers. I despise the please excuse my dear Aunt Sally, even though it's like the only way to teach it. And it's not because it's not technically wrong, but it's because it typically leads people to believe certain things. So when I come into this, I'm actually going to be doing two things in each term. I'm going to be multiplying each term by 12, but I'm also going to be dividing by the denominator. So my question to you is, who's bigger, multiplication or division? Because I'm going to be doing both, and so I need to know the order in which I have to do them. And I know some of you probably right now are going, well, yeah, you have to do them left to right. Awesome. Except in multiplication, I can change the order because it's commutative. So who's left and who's right? I can change that. And then others are going to be going, well, multiplication because it comes first, and PEMDAS because it's please excuse my dear Aunt Sally. Again, that is the reason I hate it, because it implies that multiplication is bigger than division and addition is bigger than subtraction. Division and subtraction are kind of shortcuts. They don't truly exist as far as the operators that we talk about. Multiplication and addition, however, are the ones defined on the real numbers. Division is defined in terms of multiplication. Subtraction is defined in terms of addition. So they're really not themselves in operation. They're cheats. Multiplication and division are the same thing, which means that they can be done in any order. Now, I know some of you are going to say, well, yeah, but see, division, you can't commute because 2 divided by 3 and 3 divided by 2 are not the same things. You're right, absolutely. However, if I divide by 3 by 2 and I multiply 3 by 1/2, it is the same thing. Now I can flip the 3 and the 1/2. So if I'm doing a complex set, I can move them around to where I need them to be. So that's a fairly long and involved explanation of why I'm going to be able to do the things that I'm going to do to make my life easier. We are multiplying everything by 12. That you can think of that as 12 over 1. I always draw these in. I'm 40 years old. I've been teaching for 8 years at the college level. I still draw these in because I will screw this up in a heartbeat. So I recommend that you do something to kind of remind yourself that it goes along to everybody. You don't have to draw the little claw, but just make a note to yourself somehow that, yeah, all right, everybody gets one. All right, so now when we multiply fractions, we multiply straight across. So the 12 is coming in on the numerator. Well, 12 times 5 might not be all that easy of a thing to do. However, 12 also has to get divided by 6 at some point. I'm going to choose to do that first because I'm allowed to exchange the order of multiplication. I'm multiplying 12 by 5, and instead of dividing by 6, I'm multiplying it by 1/6. I just take the shortcut and divide instead. So 12 divided by 6 is 2, times 5 is 10. 12 divided by 3 is 4, times 5 is 20. Notice I'm keeping the signs in between. I'm not multiplying by a negative, so I'm not changing any of the signs. 12 is coming into the 3/4, so it's 12 divided by 4 for 3, times 3 for 9, so this is going to be 9x. Plus, and then 12 divided by 2 is 6, times 1 is 6, and the x comes along for the ride. And what I've done effectively is I have changed the look of the equation into something that perhaps might work a little bit easier for you. It does not change the answer, because that is a critical piece of algebra. You are allowed to multiply both sides of an equation by any non-zero number, and you will not change the equality of it. So it keeps it alive. Continuing on. That was 1a, so after I've distributed, I would have gone ahead and cleared these fractions. My step 2 is to combine like terms on each side individually. On this left side, the only like terms are 6x and 9x, and I add them for 15x. Since I'm not doing anything to the other stuff, I'm simply going to bring it down. The next step, step 3, has to do with it has to do with addition and subtraction, and I'm going to move all of the x terms to one side and all of the number terms to the other side. Just the terms. Just the terms. So here I'm going to go ahead and I'm going to subtract negative 20, but subtracting a negative is like adding. And so a lot of people just say, well, what are you doing to that term? Do the opposite to get rid of it or to move it. In the end, we don't want that term there, so that term must become 0. Because 0 plus anything is just going to simply give you that anything. So in this case, I have 15x plus 0 because negative 20 plus 20 is 0. That's going to give me 15x. Over here on this right-hand side, I've got 10 plus 20 for 30. And then finally, step 4, once you get to this point, you should always be in the same way. Now, granted, if you're looking at this and you're saying, well, wait a minute, I got x's, y's, and z's in mine, you're going to need to do something different. And there's different techniques that will work. But in the beginnings of algebra, when we're first learning how to do this, you're only going to have a single variable. You can shove it to one side and shove all the numbers to the other and follow these steps. All right, so we divide both sides by 15. Always picking to do the opposite of what's happening here. The inverse undoes whatever you're doing. So if we take the inverse of 15, it's 1/15, and then we're just going to multiply both sides by 1/15. But multiplying by 1/15 is the same as dividing by 15, so that's why people do it. 15 divided by 15 is 1. 1 times x is just simply x, and then 30 divided by 15 is 2. Now the proper way to deal with this is to then take this answer and we are going to put it back in for x in each one of these terms and check it to see if it works. Because it is possible that you get an answer and it doesn't work. Even though you've done all of your algebra correctly, you get an answer that's wrong. Usually that's called an extraneous root. I have other names for it that are somewhat more derogatory. But here we go. Anytime you're making a substitution for a variable, or anything for that matter, you're always doing it in parentheses. This will keep a sign error from happening later on. Notice I am not putting it into my orange equation. Because if something bad happened in that set, or between these two steps, this will find it. So I go back to my original equation, complete with fractions. So here we go. 2 times 1/2 is 1. So I'm just cleaning this up. 3 times 2 is going to give me 6. So this is going to be 6 over 4. Minus 5/3 is equal to 5/6. And that's a question, really. So getting a common denominator and squeezing stuff together. This is going to be, I'm going to reduce this 6 over 4 to 3 over 2. And then I'm going to get a common denominator of 6 on everything. So this is going to be 6 over 6 plus, and then I have to multiply top and bottom by 3, so plus 9 over 6. And then subtract, and then by 2, so 10 over 6 is equal to 5 over 6. By inspection, you see that it's 6 plus 9 is 15, minus 5 is 5 over 6. And is that true? Yes, it's true. It checks out. So the solution 2 is the solution to this particular equation. Now, do you have to check every single time? You should. Will you? Probably not. You'll get a feel for when the check is necessary. It's not typically critical on linear equations, but it's always a good idea to check because it's the only way you know if you're getting it right, other than just knowing the answer. All right, we're going to take a look at a couple more. The next one is without fractions, but it has distribution in it, so you can kind of see how that's going to work. So my very first step is to distribute. So I'm going to go ahead and distribute the 8 across the 3x and the 10, and the 4 across the 5 and the negative x. That doesn't change any of the signs when I do this because neither of the 4 nor the 8 are negative. So 4 times 5 is 20. 4 times negative 1 is negative 4x. 8 times 3 is 24x. 8 times 10 is a positive 80. Well, I'm going to do something a little funky here. And I am going to actually move along kind of to step 4. I'm going to do the opposite of clearing the fractions. I'm going to reduce the whole numbers. It's something that I could have done in the last set at a certain point. But if you notice, all 4 of these terms are divisible by 4. It actually gives us a hint that we could have just started by dividing both sides by 4. Perhaps if I have a little bit of time at the end of the video, I'll show you what I mean. But anyway, what I'm going to do now is I'm going to go ahead and I'm going to divide everything by 4. So both sides are going to get divided by 4. When you do this, that division gets distributed because it's multiplying by 1/4. And so 20 divided by 4 is 5. You'll notice that you just pop down and, oh, that 4 magically disappears. But over here, you get 6x plus 20. It's like these two just get doubled because that's actually what happens. If you divided 8 by 4, you'd get 2. So 2 times, and then you distribute the 2. Well, these numbers are a little bit easier to work with, so now we can just go ahead and work with these. It is not necessary that you move to a particular side. Given that I know that inequalities have an extended rule on negatives for multiplying and dividing, I always try to move my variable terms first, and in such a way that I have a positive number of them. I don't care what the number is, just as long as it's positive. So my choice is just simply going to be adding x to both sides. Now, negative x plus x is 0x, but 0 times anything is 0, so therefore it satisfies that term going away. This is called elimination, by the way. It's not cancellation, it's elimination. Then 6 plus 1 is 7x, and then I have this plus 20. If I subtract 20 from both sides, then 20 minus 20 is going to give me 0. That goes away and becomes 7x. And then 5 minus 20 is a negative 15. And then finally, I go ahead and I divide by 7 on both sides, and so I get negative 15 sevenths is equal to x. And you're like, yuck, I don't like it. The x is, that's perfectly fine. There's a property in inequalities called the symmetric property, in that if you have something equals x, you can reverse them and say that x equals that something. So if you don't like that, you can just simply reverse it and say that x is equal to negative 15 over 7. The signs do not change. So there's our answer. Now, it would be good of us to go back and check that. However, I'm looking at that going like, those are some nasty fractions. I'm going to take a leap of faith. I'm just going to say that it works and hope for the best. So those are our answers. So I have a little bit of time. I'm just going to go ahead and kind of show you what I meant over here. In that second step, I divided by 4 to remove those larger numbers because I noticed that everything had a factor of 4 in it. I could have done the same thing here where I have 4 times a bunch of stuff is equal to 8 times a bunch of stuff. I could actually divide both sides by 4. Now, because I'm multiplying these two factors, the 4 and then the 5 minus x, I'm only dividing one of them. Division does not distribute amongst multiplication. It distributes amongst addition and subtraction. So it's 4 divided by 4 for 1. And then it's 8 divided by 4 for 2. Nothing happens to the stuff inside the parentheses. And then at this point you could distribute, which is going to give you that 5 minus x is equal to 6x plus 20. Yeah, I didn't do that, but believe me, in my head I was drawing them. So you'll notice, again, we're at the same spot. There's lots of different ways to solve these. So just pick a way that works best for you, kind of truck along that way until you just got it down, and then you can start looking for little tricks and tips along the way. Or trips, who knows, you can just combine the two. Okay, last one. Hopefully we can do this in a reasonable amount of space because I didn't give myself much. But this one has distribution, it has fractions, it has all sorts of goodies. All right, so it looks like 3 plus a bunch of stuff. I'm not going to worry about that. What I am going to do is I'm going to go ahead and distribute all of the parentheses out. So I've just got everything out in the open. So this is going to be 3 plus 1/4 x. And then minus 1/4 of 4 is 1. 2/5 times 2 is going to give me 4/5 plus, and then 2 times 3 is 6/5 x. At this point, because I've got weird numbers on the bottom, so I'd have to get a common denominator anyway, I'm going to go ahead and I'm going to multiply everything by 20. 20 is the least common multiple of all of the denominators. And so I'm guaranteeing myself that at least I'm going to cancel out the denominators. So again, the 20 is coming in on the numerator, so I've got to divide by the denominator. I'm going to start on the left this side and just work my way over to the right. So 3 times 20 is 60, plus 20 divided by 4 is 5, times 1 is 5x. 1 times 20 is 20. Notice I keep that subtraction. 20 divided by 5 is 4, times 4 is 16. 20 divided by 5 is 4, times 6 is 24. And now I've got all of that. Now, if you look on both sides and do a quick inspection, you'll notice that the 20, the 60, the 16, and the 24 are all divisible by 4. However, the 5x is not. So I can't use that little trick of dividing both sides by anything. So now I've gone through step 1. I've gone through step 1a, which is clearing the fractions. I'm going to go into step 2, which is combining like terms on each side. Addition is commutative. Subtraction is commutative. If you think of it like adding a negative, then you just take the sign with it. So I'm going to move this negative 20, and I do so in my head, but physically I would just do it on like this. Would be 20 or 60 minus 20 plus 5x is equal to 16 plus 24x. And then I would go ahead and reduce and combine like terms. So this would be 40 plus 5x is equal to 16 plus 24x. My choice is to move everything to a positive variable. So I notice that I'm going to be subtracting 5 from both sides or subtracting 24. If I subtract 24, I'm going to get a negative because 5 minus 24 is less than 0. So I'm going to subtract 5x from both sides. When I do that, I get 40 is equal to 16. And then this is going to be plus 19x. And then finally, I'm going to go ahead and subtract the 16 from both sides. And that's going to set up my step 4. So this is going to give me 24 is equal to 19x. And then I divide both sides by 19, giving me 24 over 19 is equal to x. Now 19 is prime, so we don't have to reduce that at all. It is in fact reduced. Does it work? Well, try it out. That's again, you're dealing with a nasty fraction here. So unless I have some reason to discern that I'm wrong, which could be, but I don't see anything that's just jumps right out at me. I'm going to assume it's correct, and then if it's not, I'll be unpleasantly surprised, I suppose. Now, in the real world, if you're doing this, you have to do 3 or 4 checks, because one guy going like, oh, you know what, this bridge is right, everything's good on it, right? Yeah. Okay, look up a bridge in Miami, or just north of Miami, I believe on the campus of the University of Miami, that fell. It was a footbridge, and it fell onto a freeway. I believe it killed 4 people. They just set it there and walked away. It's good. It'll be fine. No, not so much. So you really want to check your work anytime you're doing it for really. In math, nobody dies. It's when people use math to do other things that people die. So, yeah. Take heart. You're not going to kill anybody by getting one wrong yet. All right, I hope this helps everybody. Again, lots of different ways to do this. This is not the only way. If it happens to work for you, awesome. If it doesn't happen to work for you, keep looking. There's something bound to work for you. All right, take care.